This is the Tannic Titration Lab, our very last lab in room 326 that we're doing just before the winter break. And it's a good thing that we're doing it just before the winter break because tannic acid is actually found in trees, including Christmas trees, Tannenbaum, okay? So the differences between this lab is all I'm going to emphasize, same safety. The differences are, I'm not telling you which kind of acid. You're going to have to figure it out from balancing the equation. You got to balance the equation. And if you look at these, if you look at this reactant, well, that's the same base, sodium hydroxide, NaOH. But that's not the same acid. This acid is huge. The molecule is gigantic. The chemical formula, C76H52O46, tannic acid, okay? It's the thing that makes leather brown. And when we tan our skin, it's actually, people don't realize that it's actually a metaphor, kind of like making leather brown to last, okay? And then, of course, the products of this reaction are water and a salt. But that's a weird-looking salt. It's called sodium tannate, which has this formula. Okay, so if you balance the equation, you can figure out which kind of acid it is, either a monoprotic acid, or a diprotic acid, or maybe a triprotic acid. Theoretically, look, it's got 52 hydrogen. It could release anywhere up to all of those 52 hydrogen, but I'm going to limit it. I'll tell you that it's either 1, 2, or 3 that it releases. You can tell by the mole ratio when you balance the equation. If this is 1 to 1, it's monoprotic. If this is 1 to 2, it's diprotic. If this is 1 to 3, triprotic. That's how you tell. Okay, that's a lot easier to tell. So you got to balance the equation to tell that. Crazy molar mass, but otherwise it's kind of like the same setup. We have the same indicator. We're still neutralizing it, okay? And we're still using Erlenmeyer flasks. The other thing is called the burette. Don't forget what a burette is. It's a tall and skinny, it's a very tall and skinny instrument. Okay, so the differences are the acid, which is kind of a brownish acid, and it doesn't make a clear solution. The solution is tannic acid, okay? And the sodium hydroxide is obviously going to be a different concentration than what we used for the other lab. We'll also check the conductivity, and we're going to prepare it slightly differently. You'll see in a moment that I'm going to prepare it directly into the flask like I did on the last video. So this is preparing the acid. One thing about tannic acid is that it's very sticky. Once it gets into a container, it's hard to get it out. So I'm going to put it directly into my flask. I've already cleaned the flask, and of course I want to zero out the flask. But I'm going to do something a little differently this time. I've got my water measured out already, my 100 milliliters of water, and I'm going to pour some of it in before I pour the acid in, before I put the acid in, so the acid doesn't contact the glass directly. I just put a small amount of it in, doesn't matter how much, and I know the rest of it is still in here. So we're still measuring the water accurately. But of course, I don't want the mass of that water. I'm going to zero that water as well. So that's tricky, plus I don't want to overshoot the mass of my tannic acid. This is tannic acid. It's kind of a tan-colored powder. Tannic acid, of course, I'm putting in, it tells me on the lab to put in 0.33 grams of it. So I'm going to try to put that in very carefully, very, very carefully. Okay, I'm going to have to interrupt this because someone's knocking at the door. So now I've zeroed out the flask. I put in a small amount of water and zeroed that out. Now I'm going to add my 0.33 grams. I'm going to try to do it very carefully not to overshoot it. Is that zeroed correctly? Let me zero it one more time. Sometimes the atmospheric fluctuations will affect the zeroing, but I'm going to assume that that's good enough. Okay. So then let's see. 0.1. Don't overshoot it. 1, 1. Let's do about the same again. Wasn't as much as it looked like. 0.2, getting there. I'm going to go slowly. Try not to get it to stick on any surface, 0. Ooh, thought I'd overshot it for a second. Now, 0.26, I've got to put in a very small amount. 0.27, I can see what about a 0.01 gram is on this. It's just about like that. Yeah, that's about. So I'm going to go very slowly to get it as exact as I can. And a little more. 29. This should take it to 30. This should take it to 31. And then you can see like that's about 1/100 of a gram. Let's take it to 32, hopefully not 33. And this should be the last one. Now this one I'm going to put in a very small amount because I definitely don't want to overshoot it. I think I'm going to get this just right. Very small. Very small. It didn't change, didn't even register. This should do it. 0.33. Oh, it's right. It's teetering because it's rounding. I'm going to say that that's 0.33. It looks pretty good. So now I've got 0.33 of my tannic acid in the flask. Now I'm going to pour in the rest of the water. I don't have to worry about the mass of that. I'm going to pour in the rest of my water on top of it. Ooh, and I better not forget something. What's the thing I don't want to forget? My indicator. I'm just going to put the indicator in now so I make sure not to forget to do that. Because this has a faint color, notice that it's not exactly white. It's close, actually. It's close. It's not exactly clear, excuse me. I'm going to add maybe an extra drop of indicator. I think I'm going to put in 5. 1, 2, 3, 4, 5. Oh, I might have put in 6. 5 or 6 is probably good. And now I want to make sure that my tannic acid is fully dissolved. I want to make sure there's none of it on the bottom. It's actually dissolved pretty well. A lot of times it'll stick to the bottom of your flask or your beaker. That's why I'm recommending putting in a little bit of water underneath it to prevent that. Otherwise it could take you maybe up to 4 minutes to dissolve it. So now I've prepared my acid and I'm going to rest it down not under the burette. I'm going to rest it off to the side. And I've already cleaned my burette. I'm going to close it perpendicular. I'm going to put in my base, sodium hydroxide. I'm going to pour it in very cautiously, little by little, and it's going to skyrocket. It's going to skyrocket up to, let me try to stop it on the 0. I stopped it very close to the 0. Let's see if I take this out. Oh my gosh, if I take this out, it's almost exactly on the 0. I might have to let out maybe 1/10 of a milliliter. Just the tiniest bit. Oh, I went a little beyond. But you know what? This is a good example. So instead of starting at 0, well, you know what? I can start at 0.2 where it is there. I can start at 0.2. This is a good example of why we need initial volume. So I think I'll just do it that way. I'm going to write 0.2 as my initial volume. So notice I'm going to start off, my burette was not at 0, it was at 0.2 milliliters. So now I will have to subtract, I'll get a different titrated volume just to show you why they even have this box. It doesn't have to be 0. Okay, so now I'm going to take out my waste beaker and I'm going to put the flask underneath that contains the acid and the indicator, and I'm going to begin to add splashes of color. Okay, I'm going to begin to add, base. And as you can see, splashes of color are forming. It might not be as obvious as last time. The base is at a different concentration than last time. So don't expect everything to be identical. Okay, I'm racing through some of this just because I have some idea where the titration will occur, and I don't want this video to be long. Okay, but you should, at least the first time, go pretty slowly. The second time, when you're repeating the experiment, then you can sort of get close, okay, get maybe 5 milliliters before you know it's going to titrate, and then proceed at a slow pace. So I'm going to do that as if this is my second time doing it, okay? And notice all that color down there. Okay, it's disappearing fairly quickly, meaning that the acid is neutralizing it. It isn't spreading out. Now the tricky thing about this is we won't necessarily get the pink color. We won't necessarily get this kind of faint pink color like we got from the oxalic acid, because oxalic acid is perfectly clear, whereas tannic acid, on the other hand, is a little bit tan, as you can see there. It's not perfectly white itself, so that's going to mix with the pink color, make sort of a peachy color, okay? So now I'm going to go a little slower till I see it start darkening. Notice that I'm adding the base, which is clear, and what that serves to do is it kind of dilutes the acid, okay, as well as partially neutralize it. So what all you should really see is the color getting lighter and lighter. You shouldn't really see a darkening or any significant darkening until the indicator phenolphthalein is showing up. So phenolphthalein will show up when it becomes a base, okay? So when we're just getting rid of the last bit of acid, the phenolphthalein will show up. Now I don't think I'm seeing it yet, but I'm not sure. It's a little hard to tell. These colors can be very faint. So I'm going to keep a close eye on this. Okay, this is my first try with this, so I know I'm getting close. Okay, and when I start to see any indication of a color change, sort of a peachy color, that doesn't go away, I want to record that. I'm going to start recording my volume soon. Let's see. Let's see if that goes away. Still kind of going away, so I'm going to keep going. Notice I'm adding just a splash at a time. Oh, wait a second. Ooh, you know, now I think I'm starting to see something. I'm not positive, but I'm going to start recording the volumes, and I'm going to write them on the margin, just in case I'm right. I think I do see some faint peachy color in there. So it's right now, it's at 30. If you look on here, it's at 30.2 milliliters, okay? So I'm going to put this back. I'm going to write down 30.2. I'm just going to write it on the margin just until I confirm it. That might be my final volume. I just don't want to write it in there until I'm sure. So if I'm right, it should get darker now. Let's see. Does that look darker? I'll put in a big splash. This doesn't titrate. This doesn't go on the curve quite as steeply. I think I definitely see it now. If you can see that color, you can see that color better with this behind it. But it definitely has some darker color. So a darkening indicates, so this is kind of confirming what I thought. So I'm going to now add more to see the color really show up. Okay, now it's getting nice and peachy, nice peach color. So I think that was it. I think I was actually correct about where I was. And then what I'm going to do is see what happens when I add a whole lot more of that. Okay, add a whole lot more. Look at when the indicator really starts showing up. Okay, so when the indicator really shows up significantly, well then the pink color overwhelms the tan color. So it gets closer and closer to what you expect from phenolphthalein. I'm going to wipe this off the bottom. That's affecting the color there. Okay. Okay, and then of course, if I add more and more, it'll get darker and darker. So now we've obviously got a base. Okay, at this point, it's clearly gone beyond neutralization, which is okay because we can pour bases down the sink. Okay, and then I'm just going to let the rest of it pour in there so we can see when the color gets really dark, when the indicator is showing up completely. And now it's looking closer to what we had in the other lab, okay, because now the base is accumulating in the flask. So now it's very obvious, okay? It wasn't so obvious when I called it. It's very faint, but I think I was right. Okay, now we're just going to see what happens with a whole lot sodium hydroxide. Okay, well that's not dark enough. Let's just see what happens when you add a whole lot. There we go. That's the stereotypical color for phenolphthalein, that really dramatic purple. So at this point, now it completely overwhelms that faint tan color. But when it was first showing up, it didn't. So I am going to use that 30.2. I'm going to write it right here, 30.2. And then how am I going to get my titrated volume? This minus that, final minus initial, will give me my titrated volume. I can calculate the molar mass of this crazy monster. Okay, calculate the molar mass, and then divide this by that to get the moles. I know the amount of water that I put in is on the instructions right here. The amount of water I put in, that's my volume. And then if I balance the equation, I can figure out if it's a monoprotic, diprotic, or triprotic acid. That'll help me figure out how to get the concentration of my base. Also, it asks for the molar mass of the base. Even though you might not really need that for any calculation, those are two of the answers. Make sure to put the units. Make sure to put the units for concentration. The lab report is located right here, and you can probably write the lab report here, the steps of the lab underneath. You could probably fit it right there. Okay, so this lab, since you've already done one, should go a little faster. Try to finish it up, our very last lab. And in this case, it's the last lab that we're ever doing in room 326.